This project came to mind about 5 years ago, right before I started college, and I kind of been designing it as my degree progressed. And I actually had the original gear design made 5 years ago, but then this year in senior design, we evolved it into what it is now, which is a final product. So, and yeah, the project stemmed from me wanting to, not being satisfied with what was available for me to find, so I needed to make it.
So in August, we started the project. In October, we huddled together, came up with some group designs, came out with about 20 different design iterations for the gear leg. And then in November, we decided on a Porter style design.
Why the Porter gear? Well, the Porter gear, it enables you to get a lot more travel, especially in the vertical direction, which is the direction that you absorb the impacts under. So the standard Cub gear has limitations in travel due to the fact that the gear, for one, it has a ton of scrub. So as the gear legs move out, as they move up, they move out almost more. So, and also the gear legs can't go up very high because they hit the wing struts. So the only way to eliminate that is move the gear legs to some degree. That's why our gear legs are now in the middle of the aircraft down low in the Porter style, meaning they meet in the middle. And you move the shocks up as high as you can get so the shocks are at as most vertical angle as possible.
And then in January, we brought up the airframe.
Here we are, leaving home. We got the airframe on top of Dylan's truck, ready to go to Fairbanks.
Nearly all of our funding is from UAF Innovation and the Center for Naval Research. We initially requested $6 grand from them to help build this gear leg and the cabane subframe and other things of the airframe assembly, but they only approved $3,500, which kind of hurt us a little bit, but it was a huge help to paying for this project.
It would have been so easy relative to this to design a suspension system for like a car. We made a lot of designs where we were like, this is bigger than any other thing we've made that we've seen. You know, we're looking at these other designs that are kind of similar, and they're using smaller tubes. They were using what looked like a lot flimsier gear, but we're running all the calculations. We decided, you know, how much force we wanted the gear to take, and based on some of those previous designs, it wasn't good enough.
Thomas had already developed our 3D CAD model from the napkin iterations. So I would bring in that 3D CAD model and I'd start doing sketches. So in that sense, I'd take the 3D object and look at it from a couple of different 2D viewports. So from the top of it, from the bottom of it, the left of it, the front, and the back of it. And from there, I would sketch dimensions. So I'd measure important lengths, important angles, and then I'd label what each part was so it was really easy to read, and some set tolerances. So then we would print that out and I'd hand that over to Thomas or Sam to machine and begin welding.
Okay, let's stick a plate on there. I welded everything on this, actually. I was the primary welder. So we started with the cabane V. We had to tack it all in place. We had a pretty funky setup. We zip tied some speed squares onto the tubes, held the whole thing together with the airframe upside down, and then tacked it all in place, tacked the crossbars in place. And it was a lot of really precarious welding to try and make sure that there's no heat warping. Because we basically had a V like this. It's not triangulated. And so as soon as we weld, it all pulls together. If we weld on the other side, it all pulls apart. If we weld in the middle, the side tubes come together. And that took a ton of time back and forth. We ended up having to do some extra welding, extra like hot passes to try and pull the welds. And that was something not brand new to me, but I was not very good at. It took a while to like dial that in. It took a lot of mentoring from the shop supervisor, Wilhelm, who was super helpful.
For me right now, the gear is definitely a one-off. In this aircraft will be a one-off for sure. The gear could be commercialized though. The gear has total potential to be SDC'd for a Super Cub. It's what the FAA considers to be a legal modification to a standard type certificate. So if you have SDC for an aircraft, you can perform that modification to it legally and operate it either commercially or non-commercially with it.
I don't think there's one out there that's gone through this much design for a Piper Cub. We're really confident in how strong it's going to be. I think it's going to work really good. There's nothing nothing like it anywhere else.